Welcome back everyone. This is Muthuminal, Assistant Professor at Department of Agricultural Engineering. This session covers the continuity of soil water retention, its retention rates as in infiltration. We'll see in a detailed manner about the infiltration and factors influencing infiltration rate under the subject irrigation and drainage engineering for third year agricultural engineering students under the topic soil water tension and measurement of soil water. Before going into the session, we'll have a small recap. Until this time, we have seen something about soil water retention, and then we have seen how the soil texture gets affected with water holding capacity of soil, and also we have seen something about the retention ways and what are the forces that causes major responsibility at the water retention in the soil. The first one is cohesion and adhesion forces, and this is the pictorial representation of how the adhesion and cohesion act towards each other in order to provide the retention rate. And also the next secondary thing is surface tension, where the capillary activity plays a major role, and this phenomena is usually evidenced at the water and air interfaces. The third thing is polarity or dipole character, where the retention of water molecules on the surface of clay is based on the dipole character of the molecules of water. These water molecules are usually held down by the electrostatic force, and here the electrostatic force plays a major role instead of the forces, and due to which that exist on the surface of colloidal particles, which causes the dipolar character, under the influence of which the molecules of water get oriented on the surface of the clay particles in a particular manner. And the fourth way is why we have to depend on the factors, because there are seven categories where the soil water gets affected under these retention level. The first one is texture, second is structure, third is the organic matter, fourth is density of soil, fifth is temperature, sixth is salt content, and the last one is depth of soil. Usually, as we have seen at these several sessions, we are evident that the finer the texture, the more pore space and also the surface area, and greater the retention of water. Well aggregate porous structure favors better porosity, which in turn enhances water retention. And also, higher the organic matter, more is the water retention in the soil, and higher the density, lower the moisture content. We also do know that the cooler the temperature, the moisture retention will be in a really high, and it is evident that more the salt content in the soil, the more water available to the plant. And also the depth of the soil plays a major role, since more the depth of the soil, the water available to the plant will be in a more. That means that whenever the depth of soil is larger, the pore capacity gets increased, and also the availability of gravitational force will be higher, as I have shown in the water holding capacity that affects the soil texture. These are some kinds of factors that usually affect the soil water level. And also we have seen something about how the water gets retented and what are the waves to maintain the retention due to three primary ways. One is the cohesion and adhesion force, second one is the surface tension, and third one is due to the dipolar activity. So these three are really necessity for us in order to manage the soil retention. Along with it, we have also seen something about what are the factors affecting soil water, and also in the near future we will see something about what is infiltration and what is the rate of infiltration in a soil, and what could happen if the infiltration rate is increased or reduced. That means that the factors influencing infiltration rate will be studied in a detailed manner. This is what I have prepared for today's class, and see you at the next class. Thank you.